Good afternoon, ladies and gentlemen. Let us discuss about part of the great circle sailing today. We have already seen about the significance of sphere and Earth being a spheroid, and if you draw the Earth as a spheroid, but all practical purpose, we are taking the Earth as a true sphere. On the surface of the Earth, if you take the equator and the North Pole, South Pole, any part of the Earth, if you are proceeding from place A to place B, then the shortest distance between 2 points, for example, if I have point A and point B, and these 2 points, if you take it as the point of departure and point of arrival, the shortest distance between the 2 points would be given by the arc of the great circle. If I draw an arc of the great circle arc will be curving towards the pole in which you are located, or the greater the latitude, wherever, that side the arc will be curving towards that particular pole. We have also seen that meridian is the semi-great circle which is joining from pole to pole. If you draw a meridian through point B and also the point A, meridian being a great circle, and the arc of it which is joining between the pole to point of B and point A will be also called a great circle arc. When you have 3 great circle arc, conjoining them and then intersecting and forming a triangle, that particular triangle is called spherical triangle. We have already seen this in the earlier class. And if you take pole A, B, they are all 3 points. This particular spherical triangle has got specific properties. That is to be kept in mind at all times. And again I repeat, on the true sphere, the shortest distance between 2 points are given only by the great circle arc, not the small circle which is the parallel latitude. When you have 3 arcs of the great circle intersecting and forming a triangle, it is called the spherical triangle. This spherical triangle have got 6 angles. Let us look at it. The included angle between 2 meridians, which is the difference in longitude or d long, it is an included angle denoted by angle P. And also between the meridian and the great circle arc, it is the capital A which is denoted, it is another included angle. And you have between the meridian of PB and the great circle arc, we are intersecting another included angle. All 3 included angles, when you add up the specific property, what is said that angle P plus angle A plus angle B, it will be always more than 180 and less than 540 degree. This has been learned by you in semester 1. And another unique property of the spherical triangle is the opposite side is named with a small letter. If you take included angle A and opposite side is small a, which is an arc of the great circle. Angle P, included angle, opposite side is small b. Angle P, the opposite side is small p. All 3 sides, when you add up, as per the property of the spherical triangle, angle A, angle P plus angle P will be always less than 360 degrees. These properties are the main one for resolving the spherical triangle. Gentlemen, let's look at the next step of resolving the spherical triangle, and so that we look at the great circle sailing part. Now we require to know the relationship between the included angle and the opposite side. And the sign of opposite side and sign of included angle which is opposite to that particular arc has got a distinct relation when you divide by them, which will be equal to sine of B by sine B, and similarly the sine of P divided by included angle sine P will be also same. Another point we have to keep in mind, the cosine formula. As per the cosine formula, when you have to resolve this spherical triangle side, then you can take cos of a side. Suppose let's say take cos A which will be given by product of cos of other two sides, that is cos B into cos P, plus product of side of sine product of other two sides, that is sine B into sine P, which is multiplied by the opposite angle cos of A. With this cosine formula, you can resolve the spherical triangle. Now let's come to the practical part of the sailing. The ship has to traverse from point A, which is the departure port. Now, at the time of departure, you want to know the initial course, what is to be steered, which can be found by looking at the angle A. The included angle A required to be found. After having found the included angle A, we need to know what is the course. What is the definition of the course? Course is from true north to the ship's head. Ship's head pointing about this direction, and the A is this. So from true north to the ship's head is called true course. Whereas in the case of final course, you would be getting the angle B by resolving this spherical triangle. However, the ship would be proceeding at this juncture. What would be the ship's head? It will be pointing towards this direction. Here, the complementary angle between the meridian to the ship's head or from true north to ship's head is the final course, which is 180 minus angle B, to be kept in mind. Similarly, we can find out the angle P also. But however, we know the angle P, which is nothing but difference in longitude. That is the longitude of departure port, longitude of arrival port. If you find out the difference, that gives the angle P. This being the fundamental of spherical triangle. From here, we have to advance towards finding out the composite track sailing. Again, let's take an example of the true sphere. If you are proceeding from one part to another part, that is, let's take, if this being the equator, from A to B, and the great circle arc will be curving towards the pole and arriving at point B when you leave. Now, we need to keep in mind, when you are proceeding on the great circle track, you would be initially heading towards a particular course, and you would be gaining latitude as you go up. As I told you initially, the latitude will continue increasing up to a point called vertex. When you reach the vertex, you would be gaining the maximum latitude. After that, latitude will reduce. In other words, you would be pointing towards a particular northeasterly course in this case, and the ship would be proceeding northeasterly. Suppose in this case 020, 030, 040, 060. Then once it arrives at the maximum latitude as it curves towards the pole, that point will be reached where it has attained the maximum latitude. At this juncture, it will be pointing exactly 8. After that, the ship would be pointing towards from northeasterly quadrant, start pointing towards the southeasterly quadrant. And this point, when you call this, when you draw a meridian from pole, is called vertex. Gentlemen, at the vertex, the angular value which is intersecting the great circle track will be exactly 90 degrees. And for which you have to keep in mind, if you draw a meridian to another, wherever it intersects the equator, meridian would be intersecting at 90 degrees. That to be kept in mind. And now, vertex you have resolved with a spherical trigonometry. Suppose you found, let us take an example and understand it. You have left the harbor from 10 degree north and wanted to arrive at 45 degree north, the port located. and Vertex has taken you up to, suppose, let's take 60 degree north. Due to some unforeseen conditions or weather bulletin, and anything above 55 degree north, suppose that is not conducive for navigation, ice formation taking place, and dangers exist, and you and the chief officer are recommending to captain, let us limit our sailing on the great circle track only a particular latitude. So the captain gives the consent and he says, okay, let us not go to 60 degree north, which is the vertex point, but let's limit it at 55 degree north. Suppose you take 55 degree north and draw a parallel. Where you are commencing your great circle sailing and reaching the point where it is going to attain the 55 degree north, thereafter you do not proceed on the great circle sailing, then you resort to the parallel sailing along the latitude 55 degree north. Thereafter, when you again start intersecting the great circle track which you had earlier planned, at that point onwards, you would be pointing towards the southeast quadrant, and then you again once again carry out great circle sailing to arrive at the port B. If I have to redraw this particular picture, then it would be you are climbing up and thereafter arriving at 55 degree north latitude, then you are reaching point B. So what is happening? You have got a segment of great circle sailing, parallel sailing, and another great circle sailing. Now when you make a diagram, suppose this happen to be the pole, and you have all meridians drawn from the pole to the point A, point B. Even though this great circle track would have taken you to higher latitude, which will be the vertex, but you have prevented it because of danger existing. Now this parallel latitude, where it meets the meridian, parallel latitude is again parallel to the equator. The meridian and the parallel latitude will also intersect with an angle 90 degree. Now if you name this as V1 and V2, because again the angle is 90 degree. What is happening? You have three triangles which are formed. But here the point to be kept in mind, you had A to B along the great circle track, it was a great circle. Whereas we have decided deliberately not to proceed up to vertex because of danger. The part of the great circle is taken between A to V1. So if you take specifically this triangle of PAV1, you have a meridian between P to A and you have meridian between P to V1, both being a semi-great circle that forms the arc of great circle. Here again, it is the great circle arc which is joining AV1. So the triangle PAV1 is a spherical triangle. Similarly, let us look at the arrival port B. You have the meridian drawn from pole to point B, which is another great circle arc. You have once again carrying out great circle sailing between V2 to B. It is the great circle arc. And you have the meridian drawn from pole to point V2. Meridian again, semi-great circle, it is a great circle arc. When you join all three great circle arc forming a triangle, this is also a spherical triangle. However, we have to keep in mind, when you do a parallel sailing, here you have joined both V1 and V2 from the pole with a meridian, both have the mark great circle arc. However, V1, V2, which is the parallel latitude, and if you come back to this Earth's surface, equator is the great circle, meridian is the great circle, whereas when you have parallel latitude, the center of the parallel latitude circle does not pass through the central sphere, so it is not a great circle, it is a small circle, which is already taught to you earlier. Now, being a small circle, the parallel latitude will be also an arc, but it is a small circle. This particular triangle, that is P, V1, V2, hence cannot be called as spherical triangle. So we cannot use the spherical trigonometry to resolve this particular triangle, even though you have two adjacent spherical triangle which can be resolved by either Napier rule for right angle spherical triangle or cosine or sine rule. We can resolve it. Then how do we resolve that? We need to resolve that triangle to find out the distance V1, V2. If you take this particular one, you have distance along the equator between two meridians, east-west distance, it is nothing but the distance. Whereas the same one is also equal to the d long at the pole, difference in longitude. But as we go up towards the earth, towards the pole, either north or south, this particular distance, east-west distance, reduces in the ratio of cosine of the latitude. Then finally it becomes zero distance at the pole point. So how do we find out the distance east-west at a particular latitude? Then we need to use the parallel sailing formula, which is derived from the plane sailing. So let us look at the plane sailing formula once again, where it says that if you have from the center, you have starting point IP A. You are proceeding to another point B. In the plane sailing, it was explained to you. That is the final position you want to arrive. This is the course you are doing. This particular course angle, if you take from in the quadrantal system, here it would be around south 40 degree east, or roughly we can call 40 degree angle. This plane triangle can be resolved by knowing the three sides. What do we know? Distance between A to B is represented by the arc AB, which is the distance. Now if we take A and B, this is nothing but latitude A, this is nothing but latitude B. The difference between the latitude is called D lat. So you know this side also, which is represented by difference in latitude. As we have seen, the east-west distance at a particular parallel of latitude is called departure. So this triangle can be resolved in a plane sailing. Now when it comes to the parallel sailing, what is happening? Your initial point and the arrival point along the parallel of sailing B, final point, whatever you call it, both of them are on the same latitude. So your ship is heading towards this particular direction. So what happened? The course angle is not there. It is exactly pointing 090 east or west if you are proceeding from B to A. In that case, this particular triangle vanishes, except both the slanting or your diagonal line which was joining and representing a distance and the east-west line of departure both get merged. So this one becomes departure and distance. As I said earlier, since the departure and distances both are same between A and B on a parallel of sailing, and we also know cosine of the latitude was dictating how much the east-west distance reduces as you proceed towards the pole, either in the northern hemisphere, southern hemisphere, the formula can be written as cosine of latitude equal to departure by d long. Departure, we know it is equal to distance. So in this case, we can take east-west distance. We are interested in finding out between A to V1, V2 to B, both of them can be resolved by spherical triangle, and V1 to V2 can be resolved by this, because we know the meridian of V1 and V2. This also I can teach you how it is to be found. Once we know the D long between these two meridians, then the D long is known. We have fixed our latitude, limiting latitude, which we call it, because we ourselves have fixed that vertex latitude I don't want to reach. So I have fixed it, suppose I take it at 55 degree north in this case. So I know this latitude. Having known two value, you can find out the departure. In this case, east-west distance, it is what the distance. So finally, the composite track is given by composite track equal to distance AV1 plus V1, V2, which is the departure and distance, then V2 to B. Both the AV1 and V2 to B can be resolved by Napier rule. V1, V2 can be resolved by this formula. Gentlemen, tomorrow we shall see about the Napier rule, how to resolve right angle spherical triangle. Thank you.